Hi, this is Leslie Langnaut, Managing Editor at Design World Magazine, and I'm here at Rapid 2015 in Long Beach, California. And I'm also here with John Murray, who is President and CEO of Concept Laser out of Grapevine, Texas. I got that right?
That's right, Leslie. Grapevine, Texas, right by DFW Airport.
So what are some of the things that you're here at the show showing?
Well, we're showcasing new products, one being the new M2 platform, which is a smaller footprint, greater filter capacity, also has dual lasers for tremendous increase in speed. So we have a lot of excitement around this platform. The M2 has been a real strong seller for us worldwide.
Now this is a laser melting or a laser sintering machine?
This is laser melting. We're a little careful with the word sintering because that implies you're not getting a fully dense part. So we avoid using the word sintering because this is fully dense metal parts.
Okay. Now, is there something that you've learned in working with metals and in laser melting? Is there some application that you kind of had a little bit of a challenge with, but you learned something from doing it?
I think the biggest challenge has been for engineers culturally, because they're used to designing with traditional tools, whether that's CATIA, NX, Pro-E, SolidWorks, and they're using those tools to build geometries that are going to be machined, welded, fabricated in traditional processes. So the challenge we're seeing is for engineers to think differently about how they're designing parts, taking away a lot of the limitations that they previously had to cope with. It was funny because I gave a presentation, showed a very complex geometry that was impossible to machine, much like this piece, and this vice president said to me, "Good heavens, John, I need to hire a bunch of 12-year-olds who've never seen a CNC machine, and those are the people I should be making my products." And it was kind of funny, but there's really a lot of truth to that.
Yeah.
This really requires a different way of thinking.
Now, tell me a little bit about this part. This thing has some very tiny edges and some very interesting geometries to it.
It does. This is an emission gas rake. It was designed by RSC Engineering in Germany, and they're a partner of ours for helping customers develop and understand how to design for additive manufacturing. So you'll see a lot of the sample of the gas comes in the front, and then it's got these features to get the flow consistent, and then it comes through these small channels, which of course would be almost impossible to machine traditionally. But with additive manufacturing, that's just another day in the park.
This was all done in one build.
This was done in one build, exactly right, and used for the end customer for this emission sampling unit.
What's the material?
This particular part is made out of Inconel.
So does it have any specific hardness or anything to it that?
It does. We have material specifications, whether that's an Inconel 718 or 625, and then many of our customers are coming up with unique alloys, which they consider a real competitive advantage, brewing their own mix, so to speak.
So you're able to take materials from other sources.
That's correct. We sell a lot of materials, and many of our customers, most of our companies use our materials, but some also do some off the beaten path development on unique alloys and mechanical characteristics that they want to get from that material.
All righty. Well, great. Thank you so much for your time. I appreciate it.
Thank you.